Hey, what's up? Welcome to this episode of Clutch Data Science. My name is Cong. I'm with my partner Zhenghua to teach you sports analytics using very interesting NBA topics. Today, we will look into the rating system of the NBA 2K games. In case you don't know, NBA 2K is a series of basketball video games. It is a simulation game, so it's based on the actual teams and real players in the NBA. And each player has been assigned a score or rating that represents their capability. The 2K company releases a new version of this game every year and updates the ratings, incentivizing heated discussion year by year. And some NBA players care about their ratings and take it personally.
As you know,
Would you like to know what your rating is tonight?
I mean, sure, why not?
I mean, LeBron is 97.
Okay.
Yeah. All
That's
right?
the best.
That's the best.
Okay.
Yeah. So you want to know your rating? Drum roll, please.
Let's check it out.
Your rating is 90. Is that good?
I mean, I feel like they're clapping because it's good,
Yeah.
but to me, it just doesn't mean.
The rating system has been discussed widely, and 2K producers also explained some of the scenarios or rules of the rating system, but we still miss the whole picture. Also, it's unlikely for them to unveil the whole algorithms because there's no perfect algorithm. Doing that would invite lots of criticisms. But given we have all the players' statistics and 2K ratings, we can reverse engineer the algorithm and develop an insight into the rules of the ratings. So in this episode, let's decode the NBA 2K rating system. For the data part, we collected all players' ratings in NBA 2K21, and this will be Y or labels of the data. Besides, we also collected players' statistics like points, rebounds, assists, and the team's statistics like win-lose percentage. This part will be the X or features of our data. One thing unique about this problem is that we are not looking for predictions because we have all the ratings. What we really want here is that we want to understand the relationship between X and Y, aka interpretations, such that we can answer questions like why LeBron is 97 while Kelly Oubre is 78. What attributes are considered more important and how do they influence the ratings? To do that, we selected a tree-based model called CatBoost. Here's a simple example of a tree-based model, just to give you a sense about the basic idea. This is the simplest form, which only looks at one attribute, average points. The model looks at points of a player, and if the value is larger than 20, then it assigns 90 as the player's rating score. Otherwise, the rating would be 60. And of course, we can make it more complicated to make the model more powerful. Essentially, the tree-based models are composed of many if-else rules. We are using a tree-based model here because this type of model is very explicable, which is the main focus of our topic. After training, the model would prioritize the if-else logic tree. We can tell the significance of each feature by calculating how well they can separate the data. CatBoost is more complicated than our example. Methodology-wise, there are two essential components: boosting and categorical attribute handling. You can look at the official website and GitHub page for more information. Here's the results of our interpretation. We used SHAP library to draw this plot, which shows the most important features and to which degree do they influence the player's rating. Let's look at the plots here. We have the color bar, which indicates the feature value. Pink means high and blue means low. Then we have the x-axis, which indicates the impact on model output. In our case, it's the rating. Next, we have the features ordered by the importance. Let's look at an example. For the most important feature, FGM mean, aka average of field goal made. If the value is very high, just like this point there, the player's final rating will be pushed up by around 2. On the other hand, if it's low, the rating will drop by around 1 point. The top 3 features are FGM, defensive rebound, and points. FGM and points represents the offensive performance. Defensive rebound represents the defensive contribution. So it's a good sign that the model attaches balanced importance to offensive and defensive features. And it is good to see that if a player makes more shots, grabs more defensive rebounds, and scores more points, his rating will be higher. Also, the lower these values are, the lower the rating will be. However, one feature is counterintuitive. Turnover is positively correlated with rating. The rationale is that more turnover indicates more usage of a player. If you look at the statistics, star players lead the turnover ranking, and role players usually do not have room or chances to make many mistakes. We are trying to be comprehensive, but there are limitations in our study. First, we are missing important information like injury, historical trend, age, etc. Additionally, our study could not claim any causal relationship. Lastly, we have limited data, around 500 players' data, which is not a large dataset. If you are curious about the coding part, I found a video which essentially replicates what we do, including CatBoost and the SHAP library. So I'll put the link in the description and I highly recommend it. Thank you for watching. If you like our video, please click the like button and subscribe to our channel. We appreciate your support.